Hey Algebra students, it's Ms.Kero and I'm going to go over the January 2026 Algebra 1 Regents exam with you. I'm going to go over all the multiple choice questions and I'm going to try to give you more than one strategy for each question so that you can understand how to do things both algebraically and using your graphing calculator when available. So let's get into it with number one. Number one gives us a parabola and it's asking us to find the equation of the axis of symmetry and the vertex of the parabola. So the vertex of a parabola is its turning point. It's either the maximum or the minimum value, depending on which way the parabola is facing. So the parabola that we have in front of us is facing upwards, so it's going to have a minimum value. So this blue point right here, that is our turning point. It's our minimum. It is our vertex. So now we just have to read our coordinates. So I'm going to go 1, 2 over 3 for my x coordinate, and then I'm going to go 1, 2, 3, 4 down for my y coordinate, so that is a -4. So I already have the vertex portion of this question. So that means I can eliminate answer choice 3 and 4, but please notice that the vertex they had, while it's incorrect, looks very close to the correct vertex. So when your teacher says, check your work, that's what they mean. They mean don't fall for the silly mistakes that the test makers are trying to catch you making, all right? So now it's between answer choice 1 and 2. Now we need the equation of the axis of symmetry to answer the second part of this question. So the axis of symmetry is going to be a line that goes through the vertex and cuts this parabola exactly in half. So this red dotted line that I'm drawing right now, that is our axis of symmetry. It goes through the vertex and it cuts our parabola in half. Now, if it goes through the vertex, that means it's going to have that same x coordinate as the vertex. And because it's a vertical line, the equation is always going to be in the format of x equals a constant, and that constant is 3. All along this line, the x value is 3. The vertex is 3, -4. The point right above it is 3, -3, 3, -2, 3, -1, 3, 0. So you notice every single point on this line, the x coordinate is 3. So the equation of that line is x equals 3, which takes us to our correct answer choice, number 1. Number 2, the product of the square root of 25 and the square root of 2 will result in what kind of number? Well, the product means that we are going to be multiplying. And if I multiply the square root of 25 with the square root of 2, it's going to give me the square root of 50. So you could just throw this into your calculator right now, and you're going to see that you get a value of approximately 7.07106, and it's not going to end, and there's not going to be a pattern visible. And so by definition, if the decimal is non-terminating and non-repeating, then it is an irrational number. Okay. The other way you could have answered this question is as soon as you got to the fact that it was the square root of 50, because 50 is not a perfect square, it has to be irrational. The square root of any number that's not a perfect square is going to be irrational. And finally, the last way you could have done this is if you know the fact that the product, so when you multiply any rational number, like 25, the square root of 25, with an irrational number, unless that rational number is 0, this product is going to be irrational. So a rational times an irrational is irrational, unless the rational number is 0, because then, of course, the answer is 0, and 0 is rational. F of x equals the absolute value of 4x plus 2, and g of x equals 3x plus 5 are graphed on the same set of axes for which value of x is f of x equal to g of x. When we see this question, f of x equals g of x, that means it's asking us about points of intersection. So we're given an absolute value function, so we know that's going to graph a v, and we're given a linear function with a positive slope, so that'll look something like this. And we are going to focus on the points of intersection of these two functions. So we're going to use our graphing calculator in a minute to graph both of these, find the intersection points, and then we're just going to focus on the x value of these intersection points because that's what my problem is asking me for. So it's important to read carefully. Let's get to our calculators and get a visual of these two functions. So I hit the y equals button, and now I already have the functions typed in here, but in case you need to know how to get to the absolute value sign, you just hit the math button, scroll right to num, and then hit number 1 for absolute value. So now we have the two functions. We're going to hit graph so we can see what they look like. And I've already adjusted my window a bit. So I increased the Y maximum so that I could see higher on this graph because the second intersection point in quadrant 1 was a bit higher than I was seeing in the original windows. So now I need to find the two intersection points, and there's a couple ways we can do this. One way is to hit second and then trace. So we got the calculate menu, and then you can scroll down or just hit the number 5 for intersect. And now I'm going to take my little cursor close to that first intersection point in quadrant 2. And the calculator is asking me, am I on the first curve? Meaning, are you on the first function? So I'm going to hit enter to tell the calculator, yes, I am. And now you see the blinking cursor has moved to the linear function. It's blinking on my red line. So I'm going to hit enter again to tell it, yes, you're on the second curve. And now it's asking me, do you want me to guess the intersection point? I'm hitting enter, and there it is. So one of the intersection points of these two functions is -1, 2. So now moving my cursor closer to the other intersection point, and we're going to follow the same process. So second trace, 5 for intersect. Now we're going to hit enter to tell it, yes, I'm on the first curve. You notice again, the blinking cursor moved to the linear function now. So we're hitting enter just to confirm that. It's asking me to guess. I hit enter yet again. And now I have my second intersection point, which happens at 3:14. The other way to get these intersection points is to hit second graph so we can get a table of values. And now, just like the problem asked us to, we're looking for the x value where f of x equals g of x. F of x and g of x are your output values, right? They're like your y's. So we are looking at our menu to see when does y1 equal y2. So just scroll down until you see when that happens. So right here is one of those values, right? y1 and y2 are both 14 when x is 3, okay? And we already knew that because we found the intersection point. If we scroll down to look for more y values that are the same, we won't find any going this way. But if we scroll up, we will see that at x is -1, the y values are also the same. They're both 2. So our f of x equals our g of x when the x value is -1 and also when the x value is 3. So looking at our answer choices, they're just looking for one of the x values where f of x is equal to g of x. So we're looking for the answer choice that either has -1 or +3, and we see that +3 is answer choice number 3. Number 4 gives us an expression and asks us to find the expression that it is equivalent to in our answer choices. So I'm going to go through 3 different strategies for solving this problem. You go with the one that makes the most sense to you, but it's always good to know more than one method. So the first thing I'm going to do is try to factor this expression. So I see that it is a trinomial. The a value is 1, so that takes me to product and sum as my factoring method. The product is always going to be the c value, so the constant, which is -120. And the sum is going to be the b, the coefficient of x, which in this case is -26. So in this problem, I'm looking for two numbers that multiply to give me -120. And those same two numbers are going to add up to give me -26. So I know that one of the numbers is negative and one of them is positive because that's how you end up with a negative product. But I also know that the number that has the higher absolute value has to be negative, because if I'm going to add two numbers and get a negative, then the higher absolute value had to be negative. So I'm going to use that fact to cancel out some of these or eliminate some of these answer choices right away. So in answer choice number 2, I'm going to eliminate because the number with the higher absolute value is 30 and it's positive. So that means if I add 30 and -4, I'm going to get a positive number, not a negative number. I'm also going to eliminate answer choice number 4 because 20 has the higher absolute value and 20 is positive. If I add 20 and -6, I'm going to get a positive number, not the negative number that I need. So now I'm down to just choices 1 and 3. So as I start to think about what numbers are going to satisfy these two equations, I come up with -30 and +4. Those multiply to -120, and when I add them, I get -26. As I've been saying with all the problems, the other choices are not random, right? These numbers obviously look very close. It will give you -120 if you multiply -20 and 6, but it will not give you -26 when you add them. Now that we found the numbers that work, we can go ahead and write this in factored form, which is x minus 30 times x plus 4. And it looks like answer choice number 1, even though it's in a different order, multiplication is commutative. So of course, these will have the same value. So answer choice number 1 is the correct answer choice here. Now, strategy number 2, in case you forgot how to factor, would be to just FOIL out these answer choices. So if we're starting with answer choice number 1, and we're going to use FOIL to multiply this binomial by this binomial, we'll see that we end up getting the expression we started with. So we're going to multiply x times x. That gives me x squared. X times negative 30 gives me negative 30x. Now I'm going to distribute the 4. So 4 times x gives me a positive 4x. And 4 times negative 30 is negative 120. Now I combine like terms, and this is going to give me x squared minus 26x minus 120. And this is the same expression I started with, which is how I know they are equivalent. And the last thing we can do is grab our graphing calculators and see if the parabola that's graphed by this expression is the same parabola that's graphed by the expression that we chose as our answer. So I've already inputted the equations into the graphing calculator. I have equation number 1 being represented with a blue parabola, and the second one is going to be represented by a red parabola. But if they are indeed equivalent, then they should overlap each other. So let's hit graph and see what happens. And you see how that blue parabola turned into the red one, showing me that they are actually the same equation. They are equivalent expressions, and that's why they graph the same parabola. While if I had graphed a different answer choice, like answer choice 2, and I try to graph it, then I would get 2 different parabolas, showing me that those cannot be equivalent expressions. Number 5, the expression 3 minus 2 radical 5 plus 6 radical 5 is equivalent to what? So when we're simplifying radical expressions, when we're adding and subtracting them, I want you to think about it like adding and subtracting like terms. So let's say this expression was 3 minus 2x plus 6x. You know that you can only combine terms that are like terms, that have the same variable, same exponent. So negative 2x plus 6x, when combined, give us 4x. And then the 3 is just going to be added to that because they're not like terms and there's nothing more I can do to simplify this. Something very similar is going to happen in this problem. We can simplify, or we can combine the negative 2 radical 5 plus the 6 radical 5. By combining what's like the coefficients, negative 2 plus 6 gives us 4. We're going to keep that radical 5 the same way that we keep the x the same when we combine like terms. And then we're going to go ahead and bring down that 3. And the 4 radical 5 was positive, so we're adding it to the 3. So we get 3 plus 4 radical 5. Other way to do this, or to at least check your answer, is go ahead and grab your graphing calculator and just input this whole expression into it. You're going to get some decimal value. And then double check, input this expression, 3 plus 4 radical 5 into your graphing calculator, and make sure it gives you the same decimal value. Number 6 is very simply a vocabulary question. Students were asked to write a polynomial given the following conditions. The degree of the expression is 3, meaning that the highest exponent of a variable term in this expression can be 3. So let's go ahead and look at our answer choices and see if we can eliminate anything. The highest exponent of the variable in number 1 is 2, so that is out. The highest exponent of the variable in number 2 is also 2, so that's out. But I see that in answer choices 3 and 4, the highest exponent of my variable expression is 3, so far 3 and 4 are in. The second criteria is that the leading coefficient is 2. Now, a coefficient is the number that's before the variable being multiplied by the variable. But the leading coefficient specifically is the first coefficient, but be careful, it's only the first coefficient when our expressions are written in standard form. So we have to first rewrite these in standard form, meaning that I'm going to write them in decreasing order of exponents. So this is going to become 2x to the third power minus 6x plus 4. So now my exponents are in decreasing order, right? It's 3, invisible 1, and 0. And then if I rewrite the second expression in standard form, I'm going to get 2x to the third power plus 4x squared minus 6. So now I see that both leading coefficients are actually 2. And so the second criteria is fulfilled by both of these expressions. So that means I have to go on to the third one, which is that the constant term is 6. The constant term being the term that does not have a variable. And so that, of course, occurs right here. And my answer choice is number 4. Number 7 asks us to identify which graph represents a function. So a function is a relation in which every input value is assigned to exactly one output value, meaning every x value can only have one y value. When we're testing for a function and we're dealing with graphs specifically, The easiest way to do it is with a vertical line test. So the vertical line test tells me that if I draw a vertical line through a graph, like I'm doing here in choice 3, and it hits my graph more than one time, then this is not a function. The reason being that if these 2 points lie on a vertical line, that means they must have the same x value, but they have different y values. But I just told you that by definition, every input or every x value is only allowed to have one y value. But in this case, it has 2 different y values. So answer choice number 3 is not a function. And we can continue this vertical line test. If I try it in answer choice 2 on the bottom left, I'll see that it fails again because it's going to hit here and here. So those 2 points I just circled, again, have the same x, but different y values. And answer choice number 4, this fails the vertical line test miserably because as I start to draw a vertical line through here, it's going to hit it here, 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 through this whole vertical line, right? All of those points between here and here all have the same x value, but different y values. So this is also out, leaving me with answer choice number 1, which is the only one that will pass the vertical line test. Every single one of these ordered pairs has a different x value. Number 8 says the following function models the value of a diamond ring in dollars t years after it is purchased. So we have an exponential function and we're being asked for the original price of the ring. Well, in an exponential function, the value that is in front of the parentheses, this is our a value. This is our principal. This is our initial amount. That's always your starting value. So it is as easy as knowing that. Answer choice number 3 is correct. If you didn't know that the number before the parentheses is your starting value, you can also think of it this way. They're asking us for the original price. So this is talking about before any time goes by after the purchase, right? Meaning that we would have to replace the t, the time, with 0. So if I replace t with 0, well then, let me rewrite this for you over here. Anything raised to the 0 power is just 1. So this becomes 1 times 500. And when I multiply those, I get 500. So it's telling me that when the time was 0, the value was 500. So the original price is 500. Number 9, the formula for the surface area of a cylinder can be expressed as S equals 2 pi r squared plus 2 pi r h, where r is the radius and h is the height of the cylinder. What is the height, h, expressed in terms of s, pi, and r? So when you see that type of expression in terms of, that means that you want everything else, the s, the pi, and the r, to be on the other side of the equal sign. And we want the height to be by itself. We want the height to be isolated. So we're going to do some work with inverse operations to get that h by itself. All right, so I'm going to start by rewriting the formula. And we're going to think about how to get this h by itself. So quite a bit is happening to the h, right? It's being multiplied by 2 pi r, and then we're also adding 2 pi r squared to it. Now, if you think about a simple two-step equation, like let's say you had 2h plus 5 equals 10, and you were trying to get h by itself. The first thing you would get rid of, even though there's multiple ways to solve an equation, the first thing you would get rid of is probably the plus 5, right? We usually get rid of the constant term first. It's just easier to solve that way. And so to get rid of it, you would do the inverse operation, which is to subtract 5 from both sides. So we're going to do something similar here. I see that we're adding 2 pi r squared to the term that has the h. So I want to get rid of that first, since that doesn't have an h in it. So I'm going to go ahead and subtract 2 pi r squared from both sides, 2 pi r squared. And what that's going to leave me with is, on the left side, s minus 2 pi r squared. I can't combine those. Those are obviously not like terms. And on the right side, these will cancel out because anything minus itself equals 0. And then 0 plus 2 pi rh is just 2 pi rh. So I'm one step closer to getting h on its own. And now I have to get rid of all these things that it's being multiplied by, the 2, the pi, and the r. And I can do that in just one step. I can do the inverse of multiplication, which is division, and divide by 2 pi r. And of course, whatever I do to one side, I'm going to do it to the other side as well. Now, on the right side, all these things except the h are going to cancel out because 2 divided by 2 is 1, pi divided by pi is 1, and r divided by r is 1. And 1 times h is just h on its own. So now I have h isolated, and on the left side of my equal sign, I have s minus 2 pi r squared over 2 pi r. And so now I'm going to be looking for the answer choice that looks like this, and I see it in answer choice number 1. Number 10, when solving the following system of equations algebraically, Mason used the substitution method. Which equation could he have used? Now, when we look at each of the answer choices, we notice that they all equal 1. So that means that he was trying to substitute into this second equation, the bottom equation. But when I look at answer choices number 1 and 2, he replaced the y with an x. You can't do that unless we're told that y is equal to x, which we are not told that. You can't just swap the variables out. He also replaced the x variable after the 2 that's being multiplied by the 2 with an expression that's in terms of x. That's not what we want either. We're replacing the variable with an expression that's in terms of the other variable. So if we replace x, we'd have to replace it with an expression that has y in it, okay? And if we replaced y, we'd have to replace it with an expression that has x in it. So 1 and 2 are automatically out. They don't make any sense. Now I'm looking at 3 and 4. So 3 and 4, you notice that he kept that 2x the same, right? Didn't substitute the x. He keeps the plus 5. And now here's where the substitution occurs. Mason replaces that y with this expression in the parentheses. And in the other answer choice, he replaces the y with this expression. So our job is to figure out which one of these is y actually equal to. Because if we know that y is equal to one of them, that's what gives Mason the permission to replace that y with one of these expressions. So we're going to do some work with the other equation, the top equation, to isolate the y so we can find out what it's equal to. So this is similar to the work we just did in the previous problem when we were trying to isolate the h, but probably a little easier. So we're going to get that y by itself. I'm going to start by subtracting 3x from both sides. So on the left side, they cancel out because that's 0. So I'm going to bring down my y minus y equals. And now I can write this as 10 minus 3x, or I can write it as negative 3x plus 10. I see that in my answer choices, the x term is coming first. So I'm going to go ahead and write it in this order, negative 3x plus 10. And now the y is almost isolated, but it has this invisible 1 being multiplied by it. So I'm going to do the inverse of that, which is to divide. But of course, I have to do it on both sides. So negative 1 divided by negative 1 is 1. So that leaves me with my y being isolated. And on the right side, I have negative 3x divided by negative 1. That's positive 3x. And positive 10 divided by negative 1 is negative 10. So now I know that y is equivalent to the expression 3x minus 10. So wherever I saw a y, I'm allowed to replace it with 3x minus 10. And you see that happens in answer choice number 3. Number 11 gives us an inequality. So let's go ahead and solve that. We're going to have to get the variable to one side. So we can either add 7x to both sides or subtract 3x from both sides. I'm going to add the 7x. That way I don't have to deal with negatives. So that's going to give me 4 plus 10x is greater than 9. Now I'm going to try to get that x by itself. So I'm going to do the inverse operation of that plus 4, which is minus 4. That's going to give me 10x is greater than 5. And now that x is being multiplied by 10. So I'm going to do the inverse operation, which is to divide by 10. 10 divided by 10 is 1. So that leaves me with x is greater than 1/2. Okay, so now I know what the answer is. Notice that the answer choices that are wrong, they gave you 2 as an answer. That's obviously a common misconception. 5 divided by 10 is 1/2. It is not 2, right? If it was 10 divided by 5, then it would have been 2. But I just point that out to say the test makers don't make up the wrong answer choices randomly. They do it using a mistake they know you're going to make. So always double check your work. All right, so we know that 1 and 2 are out. And now we're just looking at which graph 3 or 4 matches my inequality. So my inequality says that x is greater than 1/2. I can just think of this as an arrow that's telling me which way to go. And that is answer choice number 3, showing me all the values, 1, 1.5, 2, and everything else that is bigger than 1/2. Number 12, when solving this equation, the first step could be 3 times 2x plus 5 equals 7x plus 18. Which property justifies this step? So you could solve this a bunch of different ways. They're saying one thing we could have done is change it into this expression. All right, so let's look at this equation. What changed from the original to the second one? Well, it looks like that minus 8 is no longer on the left side, and that positive 10 became an 18. So how did that happen? That happened by adding 8 to both sides of the equation. 8 and negative 8 will give me 0, so it'll cancel out. And then on the right side, 10 plus 8 will give me 18. And so that's how I get that 18. So what justified that? Well, we added 8 to both sides. That's called the addition property of equality whenever you add the same thing to both sides of an equation. 13 wants to know which table of values best models an exponential decay function. So first things first, decay means that our f of x values are going to be decreasing as our x values are going to be increasing. So let's look at the answer choices and see if there's anything that we can eliminate just based off that fact. So I see that in answer choice number 3, as the x values, or the input values, they're n in this case, are increasing, the f of n values are also increasing. So this would not be decay. So answer choice number 3 is out. If I look at answer choice number 4, I see that the f of p values begin to decrease, but then after that, they begin to increase. So this is actually going to be a quadratic function. So number 4 is also out. Then we look at answer choices number 1 and 2. And so exponential functions have a common ratio, meaning that to get from one output term to the next, we're always multiplying by the same number. So the way that you can tell if this is exponential is we can just divide one output value, like let's say we take 4 and divide it by 7. So we'll do 4 divided by 7 and see if you get the same thing as when you divide a different output value by the one that comes before it, negative 2 divided by 1. You can see very quickly that this is not going to be equivalent, and so I don't have a constant ratio here, and this is not exponential. Answer choice number 1 actually ends up being linear because if you try to do the rate of change, so from going from 7 to 4 is negative 3. So the f of x value is decreasing by 3 while the x value is increasing by 1. And you'll see that that's constant. The f of x value continues to decrease by 3 every time the x value increases by 1. So when the rate of change is constant, the change in y over change in x, when that's a constant number, that means that this function is actually linear. So that leaves us with number 2 being the exponential function, but let's prove why. So like I said before, if you take any of the output values, so if we take 180 and we divide it by the one that came before it, 200, we'll see what our common ratio should be. And we get 0.9 here. So let's see if the same thing happens. If I take another output value, 162, and I divide it by the output value before it, what do I get? 0.9. And that'll keep happening as we go down that table. We'll find that the common ratio here is 0.9, and this is indeed our exponential function. Number 14 gives us a function and asks us to find the value of f of 3. All this means is replace the x with 3, right? Notice that the 3 is in the place of the x. So all we're going to do is substitute and then evaluate. So instead of writing an x, I'm going to write a 3. I'm going to copy everything else exactly as is, and then I'm going to evaluate. So this becomes the square root of 4 plus 5. The square root of 4 is 2, and 2 plus 5 is 7. So answer choice number 2 is my choice. Number 15, Isabella wants to shift the graph of the function f of x equals x plus 5 squared minus 2 left 3 units. Which function represents the shifted graph? So we can definitely do this on the graphing calculator. I'll show you how to do that in a minute. First, I'm going to show you how to just use the equation itself to know which way it has shifted. So the equation that we were given is a quadratic that's written in vertex form, which I'm circling right here. So when we have quadratics in this form, the vertex is simply hk. So notice that h is the value that's being subtracted from the x inside the parentheses, and k is the constant that's outside on its own. When I look at the quadratic they gave us, inside the parentheses it says x plus 5. So if we wanted to know how to rewrite that so that it has a subtraction sign, it would be x minus negative 5. So for it to look like the format that I gave you, we'd have to rewrite it like this, and that would help us see that the x coordinate of my vertex is going to be a negative 5. And then for the k value, which is going to be the y coordinate of my vertex, we're simply looking outside of the parentheses to see what's being added or subtracted. And that in our equation is a minus 2. So our y coordinate of our vertex is at negative 2. So when we try to visualize this problem, if you think about its parent function, if we're going to graph f of x equals x squared, That's going to look something like this, right? Obviously not exact. And then our new vertex is at -5, -2. So 1, 2, 3, 4, 5, down 2. It's going to be somewhere over here. The a value is positive, so I know it's also facing upwards. So what you notice is that from my parent parabola, the green one, to the parabola that they gave me, this equation, we notice that it shifted to the left and then down. So use that to figure out what these numbers are telling you to do, which direction they're telling you to go. If I went to the left 5, that means that the horizontal shift is happening inside the parentheses. That's the number that's going to tell me how far left or right I'm going to move. And then it went 2 down. So the number that's outside of the parentheses is going to tell me my vertical shift. How far up or down am I moving this parabola? So if they want me to move left 3 units, like I said, the horizontal shift occurs with the number inside of the parentheses with the x. That means that I'm going to be adding 3, because you see how here we added 5, but we went left. So if we want to go left, we have to add. So we're going to add 3 to what was already inside the parentheses. We don't want it to shift up or down at all, so we're going to leave that -2 the same. And so if I add 3 to the 5 that was already in there, I'm going to get f of x is equal to x plus 8 squared minus 2. And that looks like answer choice number 2. But let's go ahead and see what this looks like in our graphing calculators. So I've inputted the original quadratic into y1, so that's going to graph the blue parabola. And then I inputted the answer choice that I believe is correct into the y2, so that's going to graph a red parabola. And if I did this correctly, then the red parabola is going to be graphed 3 units to the left of the blue one. So let's see what happens when we hit graph. And that is a very easy way to tell that we are correct. So if you didn't know how to do this, you could just graph each of the answer choices until you see which one shifts your original parabola the way that the problem asked you to. Number 16 asks us to find the zeros of f of x equals x times x squared minus 36. So when we're asked to find the zeros of a function, that means that we're going to set f of x equal to 0. So I'm going to bring down the other side just as it is, but I'm setting f of x equal to 0. So looking for the 0 means that we're looking for the roots, we're looking for the x-intercepts, we're looking for the solutions. Those all mean the same thing, okay? So now after I set my function equal to 0, I'm looking at the right side and thinking about how to factor this. So when I see x squared minus 36, I'm thinking about a formula that I know called the difference of squares formula. So when I see something in the format of a squared minus b squared, I know that I could factor it so that it looks like a plus b times a minus b. Okay, so 36 is really a 6 squared in disguise, right? So it does look like a squared minus b squared. So I'm able to factor this as x plus 6 times x minus 6. And then I'm going to bring down that other x so I don't forget about it, bring down my equals 0. Now that I've set the function equal to 0, now we're saying that when I multiply 1, 2, 3 of these factors together, I get 0. Well, the only way that happens is if 1, 2, or all of them are equal to 0. So the next step is to set all of these equal to 0. So we're going to have 3 separate cases here. The first one is that x equals 0. That's the first factor. The second one is x plus 6 equals 0. And the last one is x minus 6 equals 0. So the first one, there's nothing to solve. X is simply 0. The second one, just a little one-step equation. We're going to subtract 6 from both sides, and we find out that x is -6. And the last one, we're going to add 6 to both sides to find out that x can also be +6. So here are my 3 zeros, and we can, of course, confirm this using the graphing calculator. So let's see that. So I went to y equals, I inputted my function into here, and I'm going to hit graph, and we can see that this graph does intersect the x-axis at 3 different points. And the easiest way to find those points is to hit second graph so that we get a table of values. And now we're just looking in the y column for anywhere that a 0 appears. So the first 0 that we see is when x is 0, y is 0. So 0 is one of the zeros, for lack of a better term. 0 is one of the roots, I'll say. If we scroll down, again, we're looking for when f of x is 0. So we're looking down the y column. F of x is like y, not x. If I scroll down, I see that there's another 0 in the y column here, and that occurs when my x value is 6. So x is 6 is my second 0 or my second root. And then I don't see any more zeros this way, but if I scroll up to the negative values, I find one more right here. So y is also 0 when x is -6. So we've confirmed all three of our roots or our zeros, which are -6, 6, and 0. And so that is going to be answer choice number 4. Number 17, the point x -6 lies on the graph of a parabola whose equation is y equals -x squared minus x plus 6. The value of x can be what? So they are giving us the y value and they're asking us to find the x value of this parabola. The easiest way to do this is throw it into our graphing calculator, but I'll also show you an algebraic way. So if I put that quadratic equation into my graphing calculator and I hit graph, if I want the visual, I'll see what it looks like, but really all I need is the table of values. So now I'm going to hit second graph, and they want to know what the x value is when the y value is -6. So we're looking in the y1 column for a -6. Here's one of them. So y is -6 when the x value is 3. But it's a quadratic, so you know there's going to be another moment where this happens. So I'm going to scroll up to look for that other -6. Y is also -6 when the x value is -4. And so that means that our answer is number 2. And now if you want to know the algebraic way to do it, they're giving us y. Whenever a problem gives you the value of a variable, that means you're able to substitute that variable with that value because we know what y is equal to. So let's go ahead and change the y into a -6 because the y is equal to -6. And now I'm going to try to get everything to one side of the equal sign so that this is equal to 0, so then I can use the 0 product property. So I'm going to add this 6 to both sides. That's going to give me 0 equals -x squared minus x plus 12. So now I want to factor the right side, but I'm going to start by getting rid of that negative sign that's in front of the x squared. So I'm going to do that by factoring out a -1. Okay, that'll give me x squared plus x minus 12. And so now inside of the parentheses, I can factor by doing product and sum. So my product is -12, remembering that it's always the constant value. And the sum is 1 because the sum is b, which is the coefficient of x, which in this case is that invisible 1 that's right there. So I'm looking for two numbers that are going to multiply to give me -12, and those same two numbers are going to add to give me a +1. And so after thinking about it, I realized that those two numbers are going to be x plus 4, or the numbers are going to be 4 and -3. So I'm going to write it as x plus 4 times x minus 3. So now that I have factored the right side, I can use the 0 product property and set each of the factors equal to 0, except for -1, because of course -1 will never equal 0. So if x plus 4 equals 0, then x must be -4. And if x plus 3 equals 0, then x must be +3. So here are my two possible x values for a y value of -6. Obviously the same answer that we got when we did this by graphing. Number 18, the two-way frequency table below is a summary of concession stand sales for a football game. Of the people making a purchase at the concession stand, what is the relative frequency of them buying pizza and a water? When you look at a two-way frequency table problem, that word of is kind of your key word because it's going to tell you what's going to go in the denominator of your fraction. So they're telling us that the total they want us to look at is people making a purchase at the concession stand. So when we read a two-way table, the total, see how there's a bunch of different totals here? This total is the total number of people that bought hot dogs, regardless of what type of drink they bought. This is the total number of people who did not buy any food, regardless of whether they got a soda, water, or coffee. This is the total number of people that bought water. So you always look at what two categories are intersecting at that number. So we're looking at the total people who made a purchase, period. It doesn't matter what they bought. So that means we're looking at that total of 400. Those are all the people that bought something at the concession stand. So that 400 is going to be our denominator. Now, what part of those 400 people are we looking at? Well, we want to know who bought a pizza and water. So because of that word and, that means we have to look at the intersection point of water and pizza. Those two categories intersect at the number 58. So we're looking for 58 over 400 as the fraction that's going to give us the relative frequency. And so if you just put that in your calculator and divide, you're going to see that answer choice number 4, 0.145 is the answer there. Number 19 is one of those classic conversion problems. It shows up almost every year on the Regents, so let's get to it. When Theodore was driving in Canada, his speed was 104 kilometers per hour. Theodore was asked to convert his metric speed to a different rate using the following conversions. Assuming he did all the work correctly, what would the units be for Theodore's rate? So you see they're not asking us anything about the numbers. They don't want to know the actual rate. They just want to know the units. So what does our final fraction look like? This problem is very easy to do. We are just going to eliminate or cancel out any units that are where you see 1 in the numerator and you see 1 in the denominator. So when I start to look at the first couple of fractions in this problem, first couple of ratios, I see that there is hours in the numerator and hours in the denominator. So those are going to cancel out. And I'm going to continue looking for things like that. So then I have kilometers per minute, and that's being multiplied by minutes per second. So now, again, I see another unit I can cancel out because I see minutes in the numerator and minutes in the denominator. It doesn't matter if they're right on top of one another or if one is diagonal, or if they're diagonal from each other. As long as one is in the numerator and one is in the denominator, we can cancel them out. So I proceed to look for any other units that I can cancel out, and I notice that there are miles and miles that can be canceled out. And then finally, there are kilometers and kilometers that can be canceled out. So once I've canceled out all these units, I'm just looking for what's left. So in the numerator, I have feet. Again, I don't even care what the number is because the problem's not asking me about that. And the denominator, I have seconds. And it is important that you write it in the correct order because, as I'm sure you've already seen, the Regents questions with the multiple choice are out to get you. The other choices are waiting for you to make a very common mistake. So let's make sure we go in the correct order of feet per seconds, not seconds per foot. Okay, so feet per second is right here in answer choice number 1. Number 20, which expression is equivalent to negative 2x to the second raised to the third power? This 3 that I'm highlighting as the exponent, because it's outside of the parentheses, that means that everything inside the parentheses is my base. Everything inside is being raised to the third power, meaning that I have negative 2 being raised to the third power, and I also have the x squared being raised to the third power. So now if I evaluate this part of the expression, negative 2 cubed, you could put that in your calculator. You just have to make sure you put the parentheses around the negative 2. Or we can just multiply this out, so it means negative 2 multiplied by negative 2 multiplied by negative 2. So negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. So the numerical part of my answer is negative 8. Now for the second part, you have to remember your power to power rule, which tells you that when you're raising a power to another power, you multiply the exponent. So my base will remain x, and my exponent will become 6. So the answer here is negative 8x to the 6th power. Now if you don't remember the power to power rule that I applied here, the other way you could look at this is, let's expand it out. So this means negative 2x squared multiplied by negative 2x squared multiplied by negative 2x squared. So now I have negative 2 times negative 2 times negative 2. We already did that. And now you can look at this one of two ways. The x squared is being multiplied by the x squared and the other x squared. The product rule, so when we're multiplying expressions that have the same base, we're supposed to add the exponents. So this would become 2 plus 2 plus 2, which of course is the same thing as multiplying 2 times 3. So I get, again, negative 8x to the 6th power. And lastly, if you really can't remember any of these exponent rules, once we wrote it out like this, you can expand it even further and write each of those x squareds as x times x. That's what x squared means, right? And that might help you see, okay, when I write it out, what do I end up with? 6 x's being multiplied, so that is x to the 6th power. So either way you look at it, you will get negative 8x to the 6th power for the answer here. The table below shows the amount of radioactive substance that remained for selected years. So you've got the years and you have the amount remaining of this substance in grams, and they're asking us to the nearest tenth, what is the average rate of change? So the rate of change is your change in y over change in x. Or depending on which formula you like better, y2 minus y1 over x2 minus x1. Now they're saying average rate of change because this is not a linear function. If this was a linear function, the rate of change would be constant and it wouldn't matter which order pairs we pick, we would get the same rate of change. But this is not linear. And so what happens in these problems is they tell us which x values they want us to use. So they're telling us go from 2000 to 2014. And so all we have to do is find the corresponding y values, or in this case, in this context, the amount remaining in grams. So in the year 2000, there's 750 grams, and in the year 2014, there's 25 grams. And so we're going to think of those two highlighted pieces of data as the ordered pairs that we're going to use when we substitute into our rate of change formula. Now notice that as the years are increasing, the amount remaining is decreasing. So that indicates a negative slope or a negative rate of change. So I'm going to cancel out answer choices 1 and 2 because those are positive. So now let's go ahead and substitute our x and y values. So I'm going to call this my x1, y1, and this will be my x2, y2. So if I substitute into the formula that I wrote over here, we're going to get 25 minus 750 over 2014 minus 2000. And then if I simplify this, it's going to give me negative 725 over 14. And if you use your calculator to divide correctly, you should get answer choice number 4, negative 51.8, after we round, of course. Number 22, when 2x squared minus 3x plus 4 is subtracted from x squared plus 2x minus 5, what is the result? So the reason I put so much emphasis on subtracted from is because this is the key word in this problem and is the reason that a lot of students get this problem wrong. When you are subtracting from something, that means that that thing needs to go first. If I was withdrawing $10 from my bank account, then I would do my bank account balance minus 10, not 10 minus my bank account. So whatever you are subtracting from, that needs to go first in your subtraction problem. That is the most important thing about setting this up correctly. And then obviously we're subtracting, so we're going to put a minus sign. And the second most important thing that when forgotten leads to a common mistake is that you're subtracting this entire expression. So we have to put it in parentheses because if you don't, you're just going to be subtracting the 2x squared. So we're going to write that in parentheses, and that's going to be our reminder that we need to distribute that minus sign out to every term that's in here. So this problem is going to become x squared plus 2x minus 5 minus 2x squared plus 3x minus 4. So you're thinking of this as an invisible negative 1 that's being distributed. Negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 3x is positive 3x, and so on. So now we can get to combining like terms. So I see that I have a 1x squared and a negative 2x squared. Always remember to look at the sign that's before the number and the variable in a term. So it's 1x squared minus 2x squared. That gives me a negative 1x squared, or just negative x squared. Then I have a 2x plus a 3x. So that's going to give me a positive 5x. And finally, I have a negative 5 minus 4, and that gives me a negative 9. So here is my answer, and that looks like answer choice number 3. Moving on to number 23, which equation has the same solution as x squared minus 6x equals 24? So I'll show you how to do this problem with completing the square, and then I'll also show you how to do it by just grabbing your graphing calculator, which has been the shortcut for a lot of these problems. But I see that this looks like I'm completing the square. So when you complete the square, the first thing we want to do is get the constant to the other side. It's already there. And then we want to look at the b term, so the coefficient of x, which is negative 6. And we want to take half of the b term, so half of negative 6, and square it. Okay, so we always do b over 2 and we square it. And that's the number that we're going to add to both sides of the equation. So when I take half of the b term, it gives me negative 3. And when I square negative 3, I get 9. So 9 is the number that is going to get added to both sides of the equation. All right, and when we do that, we're going to get x squared minus 6x plus 9 equals 24 plus 9. The reason we did that is because now if I'm going to factor the left side, I end up with a perfect square trinomial. So we're doing product and sum, but we really don't need to do a lot of thinking to come up with the numbers that are going to add to 9. I'm sorry, multiply to 9 and add to negative 6. The number is always going to be the same, and it's always going to be the half of b, the term that we did right in here. So when we factor this, it's going to end up being x minus 3 times x minus 3, because negative 3 times negative 3 is 9, and -3 plus -3 is -6. So now because the parentheses are the same, I can just rewrite this as x minus 3 squared. And then on the right side of the equal sign, I just add, and I have 33. And I notice that that is answer choice number 3. So now the way to do this with the graphing calculator is to just graph both the original equation they gave me, x squared minus 6x equals 24, and my answer choice, and let's see if they graph the same parabola. So if they overlap and graph the same parabola, that tells me that they have the same solution. So now before I graph it, because in our graphing calculators, it's set up as y equals, what we're going to have to do is get rid of these constants. So for the first equation, I'm going to subtract 24 on both sides. And for my answer choice, I'm going to subtract 33 on both sides. So let's see what that looks like. That gives me these two equations. So I get x squared minus 6x minus 24, and then x minus 3 squared minus 33. So let's graph these and see what happens to the blue and red parabola. Well, you see that there's actually only one because the blue parabola became the red parabola. They overlapped each other because they have the same solution. So that's how we know that's the correct answer. And the last question, number 24, says in a sequence, the first term is -2 and the common ratio is -3. And they're asking us for the fourth term in the sequence. So this word common ratio is important for us to know because it indicates a geometric sequence. The common ratio is the number that we multiply a term by to get the next term. So we know the first term is -2. We don't know the second, third, or fourth term. So we could find this since they're looking for a fairly low term. This wouldn't work as well if we were looking for the 150th term. But since we are just looking for the fourth term, we could keep multiplying because, again, common ratio means that we're multiplying by that common ratio until we get to the term that we want, the fourth. So -2 times -3 will get us to the second term. So that's going to give us a +6. +6 times -3 is going to get us to the third term, which gives us a -18. And then finally, -18 times -3 is going to get us to the fourth term, which gives us a +54. So 54 is my fourth term. Now, usually on the Regents, the problems do ask you for a pretty low number term, but in case they decide this year that they're going to put this question on and ask you for the 75th term, I don't want you to keep doing this and keep multiplying, A, because it's really easy to make a mistake that way, and B, it's going to take long. The Regents is a time test. So what you can use is your reference sheet. They give you the geometric sequence formula. So I'm going to show you how to use this now. You just have to know what each part means. The a sub n just means any term in the sequence, the nth term. So whichever one we're looking for. So our a sub n is going to be a sub 4. That just means the fourth term. That's all it means in math language. Equals a sub 1. That means, well, if a sub n meant the nth term and a sub 1 is going to mean the first term. We know the first term. We know that the first term in the sequence is a -2. So I'm going to replace that a sub 1 with a -2. The r, as you can hopefully guess in this formula, stands for that common ratio. I'm going to replace the r with -3 because they told us the common ratio is -3. And then the n, well, this n and this n are always going to be the same number. Same variable has to represent the same number. So if we're talking about the fourth term, then instead of that n, I'm going to write a 4. So it's 4 minus 1. And so now if I just evaluate this, I will find my answer in a different way. This says -3 to the third power. That means -3 times -3 times -3, which is -27. So now I have -27 times -2, and that is equal to 54. So that's how you can use your reference sheet and just understanding what these variables stand for and how to evaluate to find the same answer. All right, that brings us to the conclusion of the Regents. If there is any question on here that you needed some more help with, you want to see more examples of, just let me know. Otherwise, good luck when it's your time to take the test.